Okay, so for this one, we're going to plot the Q output of a positive edge triggered T flip-flop given the inputs below. So now we're going to practice what we just talked about. So it says positive edge triggered. And when that's the case, I like to draw vertical lines at my positive edges because I know that's the only place I can change. And we have that Q is initially 1. So Q is 1. We get to the positive edge of the clock, and we see that T is 0. Now, for T, when T is 0, there's no change. So T is 0, so there's no change, so Q stays 1. Now when I get to the positive edge of the clock, I see that T is 1. Well, when T is 1, I'm supposed to toggle. So I'm supposed to become the opposite of what I was before. So before I was 1, so now I'm supposed to be 0. And then I don't change until I get to the next edge of the clock. And at the next edge of the clock, T is 0. So no change. And at the next edge of the clock, T is 1 again, so I'm going to toggle. So this time I'll go from 0 to 1. Is that good? Okay. So I'm going to go on to this one. I'll save both of these on the same file. So this one says, consider the timing diagram below, assuming that the D and clock inputs shown are as applied to the circuit below at the right. Draw waveforms for QA, QB, and QC. Now, this top one is a gated D latch. And I don't know if you remember how those work from 2741, but I'll show you. Those get to change the entire time the clock is 1. This one is positive edge triggered. And this one is negative edge triggered. So for QA, QA can change the entire time the clock is 1. So I'm going to draw my little vertical lines here. But remember that Q follows D. And we're told that they each are initially 0. Okay, so it can't do a gated D latch, can't do anything when the clock is 0, so it just stays there. But when the clock is 1, it's going to do exactly what D does. So it's just going to follow it exactly like that. And then when the clock is 0 again, it does not change. It can't do anything. And then when the clock is 1, it does everything that D does. And that's what's making this different. This is a latch as opposed to a flip-flop. A flip-flop only changes once in the clock cycle. The latch can change more than that. So now the clock is 0, so it's not going to change. Now the clock is 1, so it'll follow the D signal. The clock is 0, so it doesn't change. The clock is 1, so it follows that signal. Okay, so now we want the positive edge trigger. So I'm going to just extend down the lines for the positive edge of the clock. This is QB 0, 1, starts at 0. Okay, so now when we get to the positive edge of the clock, you look and see what D is, and D is 1. So it becomes 1, and it stays 1 all the way until the next positive edge. Then it looks to see what D is. D is 0, so it becomes 0 and stays that until the next positive edge. At this positive edge it's 0, so it'll stay that way. And at this last positive edge it's 1, so it'll go back to 1. And then for the negative edge triggers, I'm going to extend down the negative edge of the clock. Okay, so it starts at 0. It's going to stay 0 until it gets to the negative edge. And then it looks to see what D is. D is 0. So it'll follow D. It'll become 0. It's already 0. It'll stay 0 all the way to the next edge. D is 0. So it'll stay 0. And then at this negative edge, D is 1. So it becomes 1. And it stays that way there. And at this last negative edge, D is still 1, so it will stay 1.
So would you call QA level triggered, or
Yes.
okay, so it's not negative or positive edge?
Oh, QA, yes, right. Although you do have to know there is such a thing as a latch that would change on the negative side of the clock cycle.
Oh, okay.
Yeah. So you do have to know which one it is.